Hi everyone! Ever wondered how Netflix knows what movies you'll love or how your email filters out spam? It's all thanks to the magic of statistics and probability in machine learning. Welcome back to the Knowledge Academy's YouTube channel. In the previous video of mathematics used in machine learning, we learned about data types, linear algebra and calculus. Now in this second part, we break down the maths that makes your favorite tech work. Today we're diving into the essential concepts of statistics and probability that power these incredible technologies. Ready to become a data wizard? Let's get started. Statistics is the science of collecting, analyzing, interpreting, and presenting data. It's the backbone of data analysis in machine learning, providing the tools to make data-driven decisions and predictions. There are two main types of statistics, descriptive and inferential. In statistics, we perform different types of operations like first one is mean. The mean is the average of a set of values. It's calculated by adding all the numbers and dividing by the count. For example, if we have a dataset 1, 2, 3, 4, 5, the mean for this is addition of all numbers and divide by number of dataset. There you go. This result is your mean of the dataset. Now let's see how we can do this in Python with the same dataset. For this, we will first import NumPy, then create a list of data. Then to calculate mean, we will use np.mean then, in the bracket the data or name of the list which we have created. After that, print the mean and run it. You will have the mean to your dataset. This script illustrates a basic yet essential operation in data analysis, showcasing the ease of using NumPy for numerical computations in Python. Next basic operation in statistics is finding median of the dataset. The median is the middle value when the data is sorted. If there's an even number of observations, it's the average of the two middle numbers. Let's understand with the same dataset example. In this dataset, there is total 5 number in datasets and is in sorted form, so here the middle data in the list is 3. Now let's see how we can find the median with Python. We can find the median using NumPy module. By using this, we don't need to sort the datasets. The library sorts it by itself and gives the result. So again, we will take the same dataset. We will just mess up the order a little, and you will see it still gives the correct median. First, we will import NumPy. Then we will create a dataset like this, and then we will use np.median. Then in the bracket, the created dataset. After that, give the print command for median and run it. You can see we still get the correct median with random dataset as well, because of NumPy inbuilt sorting property while finding median. Easy, right? Next topic in statistics is mode. Mode is the value that appears most frequently in the dataset. For example, if a dataset has random numbers as shown, then the mode for this dataset will be 2, as 2 has occurred in dataset most number of times. Let's take the same example and try to solve it using Python. Here we will not use NumPy library, rather we will use SciPy library, because NumPy is primarily designed for numerical operations and array manipulations. It doesn't have a built-in function specifically for finding the mode, whereas SciPy, which builds on NumPy, includes more specialized statistical functions, including the mode. So here from SciPy, we will import stats, then we will create a list, then for finding mode, we will write mode result equal to stats.mode, then in bracket the data we created to calculate mode. Then write mode equal to mode result.mode.item and a parenthesis. This line accesses the mode value from the mode result object. Motion result.mode is an array-like structure containing the mode value. The .item parenthesis extracts the scalar value from this array. Next write count equal to mode result.count.item and a parenthesis. This line accesses the count of occurrences of the mode from the mode result object. Mode result.count is also an array-like structure, and the .item parenthesis method extracts the scalar value representing how many times the mode appears in the dataset. After that, we will print the mode and the count of mode and run it. There you have both mode and count of mode for the given dataset. Finding mode is not that straightforward like mean and median, but with practice, we will get the hang of it. Now let's move to the standard deviation. The standard deviation measures the amount of variation or dispersion in a dataset. It tells us how much the individual data points deviate from the mean of the dataset. The smaller the standard deviation, the closer the data points are to the mean. The larger the standard deviation, the more spread out the data points are. Let's understand this with an example. Suppose you have a dataset and we must find the standard deviation for it. First step for it is to find mean of the dataset, and that is 3. Then we have to find the squared deviation for the dataset by subtracting mean from each value in the data and squaring each of them, and then add the numbers which we received, and then divide it from number of data present in the dataset. This will be our variance, and the square root of this variance is our standard deviation. Let's calculate the same using Python here. We will again use NumPy library. So for finding the standard deviation, we will first import NumPy library. Then we will create a list. Now to find the standard deviation, we will directly write estd, dev equal to np.std, and in parenthesis data. Then print the output, run it, and very easily and quickly you will have the standard deviation of the dataset with you. The NumPy library does all the operation on its own. We don't have to find mean squared deviation and variance before finding standard deviation. It does all the calculations by itself, and it directly gives the standard deviation. And that is all for statistics. Now let's move on to probability. Probability is the measure of the likelihood that an event will occur. It plays a crucial role in predicting outcomes and making decisions based on data. Let's dive into some fundamental concepts. First, let's learn about basic probability. This is the foundation of all probability theory. It helps us understand the likelihood of single events. For example, the probability of rolling a 3 on a fair 6-sided die is 1 by 6. Let's see how we can calculate in Python. The basic probability does not need in-depth coding as such. The code for this is pretty straightforward. We just have to define the probability of rolling a dice and getting 3. And then print it, and that's it. It does not require many things. Now let's move on to conditional probability. Conditional probability measures the likelihood of an event given that another event has already occurred. It's represented as probability of A by B, which means the probability of event A occurring given that event B has occurred. The formula for this is shown on your screen. Here PA and PB are probability of A and B. Let's take an example to understand this properly. If we have a deck of cards, the probability of drawing an ace given that we drew a heart is probability of ace by heart, which is equal to probability of A intersection B, which means ace intersection heart. This is then divided by probability of heart, as shown. Now let's take this same example and do this in Python as well. Here also we will not be doing hard coding, just some basic lines of code. First we will define the probability of drawing heart, and then ace. After that we will define the probability of ace intersection heart. And then we will calculate the probability of ace by heart by dividing probability of ace intersection heart divided by probability of heart. Then give print command for the output and run the code. Next is Bayes' theorem, a very important theorem in probability topic. It is the probability of an event based on prior knowledge of conditions that might be related to the event. It's a powerful tool for updating probabilities based on new information. The formula for it can be written in this way. Let's look at an example to understand it in a better way. Suppose if we have a test for a disease that is 99% accurate and the disease is present in 1% of the population. We can use Bayes' theorem to calculate the probability that a person has the disease given a positive test result. Let's first define the probabilities of each one by one. Probability of having the disease is equal to 0.1. Probability of not having the disease is 0.99. Probability of testing positive if diseased, sensitivity is equal to 0.99. Probability of testing positive if not diseased, false positive rate is equal to 0.1. Now calculate the total probability of testing positive, as shown. Next apply Bayes' theorem to find probability of a person has the disease given a positive test result. So from the calculations we can see the probability that a person has the disease given a positive test result is approximately 50%. Now let's see how we can perform this in Python as well. First, we will put the probability of having the disease. Next, we will put the probability of positive given disease. Then probability of a positive test given no disease. After that probability of having no disease, this can be found by subtracting probability of disease by 1. Then calculate the probability of having a positive test. After that, using Bayes' theorem, we can find the probability of disease given a positive test and print the result and run it. This is it for the Bayes' theorem. Now let's move on to probability distribution topic. A probability distribution describes how the probabilities of a random variable are distributed. It provides a function that assigns probabilities to each possible value or range of values of the random variable. There are several types of probability distributions, but let's focus on two common ones: the binomial distribution and the normal distribution. Let's first understand binomial distribution. The binomial distribution models the number of successes in a fixed number of trials. Each trial is independent, and there are only two outcomes: success or failure. For example, if we flip a fair coin 10 times, the probability of getting exactly 5 heads can be modeled using the binomial distribution. Let's see how we can do this in Python. For this, we will use SciPy library. We will take the same example. So let's suppose we flip coin 5 times. What is the probability to get heads exactly 5 times? To calculate this, we can write the code as: first, we will import binom from SciPy.stats. Then we will put number of trials. After that, the probability of success. Then to find the probability, we will write binom.pmf and in parenthesis 5, n, p. Then print the result and run it. 5, n, p, which we used in parenthesis r, number of heads which we wanted. Then n is number of trial and p is probability of success. Now let's learn about normal distribution. The normal distribution, also known as the Gaussian distribution, is a continuous probability distribution that is symmetrical around the mean. It's often used to represent real-valued random variables with unknown distributions. For example, the distribution of heights in a population can be modeled using the normal distribution. Let's take this same example and see how we can solve this using Python. For this, we will use matplotlib, numpy, and SciPy. Here we will first import numpy, matplotlib.pyplot, and norm from scipy.stats, then define mean and standard deviation. After that, we will generate data. After that, we will plot normal distribution as shown. This illustrates how data can be visualized using probability distributions. And that is it for probability section. And that's a wrap for today. We've dived into the fascinating world of statistics and probability, the dynamic duo that helps us understand and predict data. Mastering these concepts is your golden ticket to making machine learning a breeze. So, get comfortable with these mathematical tools. They'll be your best friends as we venture further into machine learning. In our next video, we'll jump into the exciting realm of ADA, which is exploratory data analysis for machine learning. Stay tuned and see you in the next video. If you enjoyed this video, hit the like button and subscribe to our channel for more exciting and informative content. Don't forget to turn on notifications so you never miss an update.